to Social Research Insights, and today I'm going to explain you what exactly is Internet of Things. For the past couple of days, I'm just thinking to provide some certain small demonstration or presentation for those people who are in a dilemma as how this Internet of Things is going to help the business management institutes, and what exactly a business analyst or data analyst need to do with Internet of Things. This dilemma is there in the industry, whether I'm working in a business management institute. I'm in a business school where there is a lot of interesting discussion whether this Internet of Things is really useful to the business management students. If at all, in case if the school need to offer a diploma or maybe post-graduation diploma in Internet of Things, what exactly need to be offered to the business management graduates? So I should say that Internet of Things, which strictly connected to the technology, is very much important for the business management students, because the ultimate end of the technology is a business organization. The technology is going to end in the business organizations. So people try to do trade with the technology, and they need to do a business setup in order to make money by selling or purchasing technology. So ultimately the technology ends in business organizations, and people always do trade with the technology. So Internet of Things is one of the emerging technologies in the industry, and there is a lot of information online, like what exactly today's or present condition of the Internet of Things, and how would be the future for the people and organizations that are engaging in this Internet of Things. And there are many other ancillary business models that are strictly connected to Internet of Things. Like we have the CNC, we have the artificial intelligence, and we have the robotics, and we have this additive manufacturing, and best practices in logistics and supply chain industry, and best practices in this transportation, best practices in healthcare, best practices in education, best practices in food and agribusiness. So these are all actually food, agri, education, healthcare, and maybe not for profit or for profit businesses. But ultimately the Internet of Things are going to do much by developing the business processes, or maybe helping a business organization earn more profit. So now coming to the very crux of this presentation, which means what exactly Internet of Things, and what need to be offered to the business management graduates, or maybe what need to be learned in order to become a best or maybe a good expert in Internet of Things or IoT industry. Today we are talking about IoE. This is actually the proposition which brought forth by the CEO of Cisco. He essentially talks about the IoE is all about IoT plus people plus processes. I'm sorry, I'm not a good plus data. So this is actually, so it is not exactly, we are not exactly dealing with the IoT, but one way or the other way we will be touching the IoE, and it is not possible for us to imagine the IoT in absence of people, processes, and data. So given that context, and we'll be dealing with the IoE most of the time. People will be dealing with IoE, not with the IoT. So now coming back to the same, like what exactly is this IoT or IoE? IoT is actually the Internet of Things. So if we speak about the things as people, then it is Internet of People. If you think about things as objects, then it is Internet of Objects. Internet of Things is exactly speaking is the things that are connected within a network. So what is that thing, and how does that can take a position within a network? So that is going to be one of the interesting discussion. The very rudimental point for Internet of Things is going to be a microprocessor. A microprocessor or maybe a microcontroller. So mostly it should be the microcontroller but not the microprocessor. So we have different types of microcontrollers, and you can the diagram which I am trying to portray here is actually called dual inline package microcontroller. So you'll find, so that there are, I'm not going to the object of this, and it will be having the pins, and we usually call it as, and this is actually the notch, like when you think about AVR microcontroller, and it is actually DEIP, dual in package, dual line in package, or whatever it is, right? And in contrast to that, we have another type of packages called QFP, quad flat package, and the shape of the QFP somehow looks like this, and most of the time we come across process that looks like that are quad flat, so you'll be having pins like this. Anyway, so these are the different types of microcontrollers, or maybe the microprocessors that we'll be dealing with. So the base for that thing in the title Internet of Things, IoT, Internet of Things, I'm just exactly talking about the thing. A thing is actually a prototype or maybe a circuitry. So in that circuit, possibly a person might be having a microcontroller with all other peripheral devices, like you can have a capacitor, or maybe you'll be having a resistor within the circuit, and all put together, and this resistor is connected to some pins, and this capacitor in turn connected to some other pins, and we have a lot of models to construct the circuits, and these circuits will be studied as in the form of the circuit simulation and network analysis, and possibly the most important peripheral devices or the components that are closely connected to a microcontroller can be a sensor. This is actually the diagram of the photosensor, a sensor, and that sensor will be having some sort of indicator components like an LED. This is actually the LED, red color LED, and here you have some sort of sensor in which, and all of them connected to the circuit, like LED is connected to some certain pins, and sensor is connected to the LED alongside the other pin of the microcontroller, and LED also can have some resistor, something like that. Okay, anyway, I'm not exactly into what is a circuit, and I'm just talking about what exactly is Internet of Things. So this is a type, if you imagine that this is a small prototype board where you have some certain components well connected within the circuit. This is, let me call it as a breadboard, where you'll be having a kind of, the connections. You can establish connections by simply piercing them through proper holes on that particular breadboard, and you have this let me put some color just to make this is a resistor, this is a capacitor, and this is, let me keep the most of the time the microcontrollers looks black, and here you have all the holes where you need to stab these components, the legs of these components, or you may be piercing these components in those holes, and this is actually the breadboard. And this is a small prototyping board, and this is prototyping board with a particular valued circuitry is going to represent a particular thing. We call it as a thing. So this thing can be a refrigerator, and it can be a television set, or it can be a the CFL lamp, or like we have some circuitry within a CFL lamp, and if you break the CFL lamp and open the bottom part of the lamp, just like here you have a CFL lamp like this, and we call this, I don't know, we have some particular meaning. So you just break this part and open this particular part, and you have a small circuitry inside with all the components. So this is actually, so you have these type of things in bulbs, in television sets, in refrigerators, and in micro oven in the kitchen, or maybe you may be having maybe the recharge lamp that we use in our LED lamp in our homes that you have. This is the handle, I'm sorry, I just wanted to. So this is actually the recharge lamp. You have a circuitry inside, and you have all those sensors, microcontrollers connected together, and the same circuitry is also there in the mobile phones, smartphones we have today, and we have those in the televisions and the computers. We have so many. So now we connect this particular module, or maybe we have those, sorry, so we have this modules. So we have a basic thing which is connected to a computer. So we'll be monitoring the, let's say for example, I'll just make up a small scenario that I have, this is a computer connected, and we have a sensor here, and this sensor is connected to the microcontroller, and the microcontroller try to pass the information to a particular computer, and this computer will display the behavior of the sensor, or maybe the what's happening in the weather, or this is environment. So it can be, we can study either the environment if you are a practitioner, and you can also study the behavior of the sensor if you are an academic. And we need a computer which is a node or a gateway, in case if you have, I forgot to tell you actually, this circuitry sometimes, not sometimes, if we are talking about the Internet of Things, then we need to have a wireless, let me push this aside, Control X and Control. So we will be having a wireless module. Let me keep that wireless module here. Today we have a lot of technology. This is a wireless module, and we have, for example, I can just talk about, it has a inbuilt microcontroller with a programmer, and it will be having so many pins again, and it can be ESP. Today we have a very cheap ESP wireless module, the name of which is ESP8266, and you also have some SIM800 if you really want to work with GSM GPRS technology. And we have low power long range modules like LoRa. So there are so many modules. So now this circuitry is connected to the ESP module, and and finally that communicates to the computer. So now we have a thing which is connected to a monitor or a display. The entire thing is going to be the we simply call it as a thing. Let me crush this to, sorry, I don't know how to, yeah, I'm not able to. Yes, I think here, yeah, now we just got a small, this is called a thing. And now like that we have several things. Sorry, this, I don't have proper tools to, so I just have to depend on the, so like that we have several things, interconnected from each other. So now this microcontroller connected to the other microcontroller, and this connected to the other microcontroller, this again, and they're all interconnected, so they all will be exchanging the data. So, and this is called Internet of Things, because we have the things, maybe this is a television set, this is a refrigerator, this is a CFL lamp, and this is maybe a recharge lamp or something like that, or maybe a motor which is running in the agricultural field, or maybe a drone, or maybe a satellite, whatever, maybe a flying machine traveling in the space. So we have all these things well connected, establishing some interconnections, and now they are transferring the data. Now this is all about the Internet of Things. Now we can't imagine this internet without assuming that they're all participating in an incessant activity called data exchange. I mean, they're all exchanging the data incessantly. Now what to do with that data? That is what is going to be the IoE. So when we speak something, this Internet of Things will take inputs and gives the output, and most of the time the output either in the form of action or maybe in the form of a letter maybe displayed on the monitor. So now we have abundant of data getting generated through this Internet of Things. Now what to do with that data? So there actually the role of data analyst appears. Now this is all Internet of Things, and we have let me clear off my we have these nodes. I'll just minimize that into a particular, let me call this is a node, this is node, this is node, this is node, and node. These are all interconnected, and a lot of data is transferring or getting exchanged between these nodes. Now we have very big data paradigm. So we have what to do with that data. So we need to collect and store and process, maybe I can call it as analytics, and report. So these are some of the important activities of the data analyst. So the Internet of Things, which means this is node 1, we have node 1, node 2, node 3, node 4, so on and so forth. Okay, now this is actually the job of the electrical engineer, or maybe the responsibility. This is just a part which is taken care by the electrical engineering. And now comes here the job of the data analyst. So We have the left side. So if I divide a line, the left side we have the IoT, and the right side we have IoE. So here IoE, actually the IoT plus data analytics or data analysis. Now for IoT we have a lot of technology. We need to go through so let me delete everything. For IoT, now what need to be a person who wanted to pursue his career in IoT, what do he need to do? Okay, especially a person who is into a particular stream of learning called business management, or maybe the social sciences. So IoT is actually a microcontroller. You will be having a microcontroller for which you need to study the microcontrollers along with embedded C, and it has the circuits. So for circuitry you need to study the circuit simulation and network analysis. We call it as circuit, sorry, my scribe is not good, simulation and network analysis, I mean circuit network analysis. And so here a person will be studying so the nature of the circuits, maybe series, how the components are connected together, whether it is in series or parallel or something. So the flow of electricity in between the components or across the network or something like that. And they got to study some sensors, the behavior of the sensors, wireless sensor networks, we call as wireless WSN. And for that we have some suite of software. And finally they also need to study the data that which is emerging from the such wireless sensor networks. So we call it as sensor data analysis. So by the time the concept evolves to the wireless sensor networks and sensor data analysis, we are in the ambit of the IoE. So I can as by that I can simply take this wireless sensor or sensor data analysis into the under a different context called IoE. So here we have sensor data analysis. So here what a person essentially do is that he just collect the data from the sensors and store that data in some place, and from there he process and later. So here these activities are going to be the collection of the data and storage of the data, and later processing, and finally reporting. So how to report the data. So here a person who would like to pursue his career in IoT or IoE need to know C or embedded C. Maybe you have so many ways to study the C. Today we are talking about the open source hardware platform called Arduino, where you have, and there is also Python. So actually if you are going through the maybe STM32 or maybe ESP8266 modules, you have MicroPython. So C or MicroPython. And for circuit simulation network analysis we have, so let me clear my dashboard so that you can not flip. So here, so the left side you have, here we have C or MicroPython, and here you have, for this is for the microcontrollers, and for circuit simulations and networking you have ngSpice or KiCad. These are all open source applications. You can also study KiCad. And for wireless sensor networks you have OpenWSN, or you can simply again take care of C and MicroPython. You need not go for this OpenWSN, or maybe that you have a couple of Linux distributions. They're all meant for the wireless sensor networks, but that is not very much necessary in order to study the wireless sensor. We can simply confine to C and MicroPython. For instance, if we would like to program the ESP8266, either MicroPython or C can accomplish the job without going to this tiny, or you have a couple of I forgot the names of those Linux based distributions that take care of these wireless sensor networks. So your job of IoT ends there. So what you essentially need to know is that embedded C, MicroPython, along with ngSpice or KiCad. So this ngSpice and KiCad essentially takes care of EDA, electronic design and automation, electronic design and automation, along with the microcontrollers and wireless sensor networks. And now coming to this IoE, so we have it is all about the data analytics. Since we came to know that a person who belongs to IoE, or maybe a person who belongs to any stream other than electronics, electrical engineering, so they will be pursuing their career in collection, storage, process and report. For those needs, a person need to know the very best and foremost software is Python. So I'm not talking about the MicroPython. This is the normal Python or general Python, whatever it is. We have 2.7 or 3 versions, and this is actually one of the giant programming languages in the world of open source software, in the world of open source or maybe free software. So but the Python, so it is better to have, you can write the Python programs both in everywhere like Mac OS, Windows and also Linux, but Linux is always a best operating system to learn or do with Python. So Python can take care of almost all jobs like collection of the data, because in IoT what happens, a microcontroller will be pumping the data to the wireless sensor module, and this module update the data to the serial monitor. So from the serial monitor the data can be collected to the Python editor, and from here we can store the data within the computer, or maybe we can divert the data to the cloud. Like you can go to the computer, or you can also go to the cloud. You have the cloud here. So from there, let us take for example, we are directing the data to the computer. We can process the data again by using the Python, and we can also report the data to a particular web page, or maybe a website, or maybe a client's place. So most of the time the clients are connected online, so they'll be watching what is happening in a particular network by getting into the network, and this network data is updated as a matter of web pages. Now Python together with HTML plus PHP plus a particular suite related to database management systems, like we can go for the MySQL. So is one of the wonderful software that caters to the needs of the desktop computing, or maybe even we can use MySQL for the network level operations. So here a person who is not into the electronics background, a person who did not have or not from the electronics background, essentially have to devote to the data analytics. One of the instances is sensor data analytics, and as such they might have to go through some important software just like Python, HTML, PHP and SQL. So Python is used in order to collect the data, store the data and process the data, and to update those processes in the form of reports. So one need to learn a host of software suites They are HTML, PHP, MySQL, or maybe you can in Python itself. There are a couple of solutions like we have Flask, and we also have Django, and maybe you can also think about Qt, Ruby on Rails kind of thing. So this is all about the IoT and IoE. I just wanted to make this video cast in order to get it clear, like what distinguishes the IoT from IoE, and what an electronics a person who has electronics background, then what he need to do, and a person who did not have an electronics background, then what he need to do. So a person who is into the electronics, then he need to concentrate on the microcontrollers. This is microcontroller, and they need to concentrate on wireless sensor networks, and they need to concentrate on how to post that data, I mean the mechanisms to update that data to the communication ports. And a person who is engaging in Internet of Everything, then they need to concentrate on those software tools that enable them to collect the data, store the data, process the data, and post that data as in the form of dashboards, maybe web reports. So this is precisely IoT and IoE. So now, since I said the objective of this webcast or videocast is to give awareness to the people who are engaging in business management, so they need to know some certain knowledge on the, not exactly everything about the microcontrollers or wireless sensor networks. They need to know something about the circuitry and microcontrollers, how the microcontroller connected to the different ancillary components like sensor, maybe other essential electronic devices. And they also have to know how to update the sensor data to the how to channel that sensor data to the serial communication ports through Wi-Fi modules. So they need to know the microcontroller, sensors, and other a couple of devices along with the Wi-Fi modules and some communication ports. But the level of knowledge can be reduced or limited to only 25% of the content, because the business management students, or maybe the people who are from the business management, they are not seriously into the electronics and they are not going to do any research. So as such, their knowledge can be reduced or limited to 25%, but the 75% of the knowledge must be dedicated to the IoE, means how to grab the data and update that data to the user interface. Okay, this is all about the distinction between the IoT and IoE, and what a person who would like to pursue his career in IoT and IoE need to prepare or be thorough of. Okay, my dear viewers, so if you like this video, please press like, subscribe to my video channel, and stay tuned for the new content. Thank you.